Hi there. So in this video, we're going to take a look at free response prep question number 3, AP Micro 2019. And as a reminder, you can always check out the scoring guidelines for these particular problems. So this is a payoff matrix showing Patrick's Pie and Dee's Pizza. And according to the setup of the problem, Patrick is actually the only producer at the beginning, and Dee is trying to decide whether they want to enter or stay out of the market. So part A says, what actions maximize the combined total profits for Patrick's Pie and Dee's Pizza? And all that requires of us is to add these two numbers together. 175 to 0, that's a total of 175. There's a total of 100, 165, and 48. So the actions that maximize the combined payoff would be Patrick advertising and Dee staying out. So we're going to put that for part A. Patrick advertise, Dee stay out. Now, part B says, conditional on your response in part A. Does Patrick or Dee have an incentive to cheat on that combination? In other words, if they're here, are they going to leave from here? In order to actually know that, well, we just compare and see, well, what would Dee earn if they switched from stay out to enter and Patrick stayed the same? So in other words, if we're still in this advertising row and Dee decided, oh, I'm going to go ahead and enter, they would end up with -2. So no, they don't, because they'd lose $2 by entering that market. Patrick, on the other hand, well, they're advertising right now. And assuming that Dee still stays out and they would switch to not advertising, they'd only get 100. So Patrick also doesn't have an incentive to leave this box. If we were to solve this payoff matrix, we would also find that that's the place that basically Patrick would really like to end up. And so for part B, we'd say no, because Dee, right, for Dee, we have 0 is bigger than -2. 0 is bigger than -2. And for Pat, we would say that the 175 is bigger than the alternative that he would get, which is 100 from not advertising. Now it says part C. Does Patrick have a dominant strategy? If so, what is it? Let's go ahead and solve this. If Patrick thinks Dee is going to enter, then Patrick's not going to advertise because 150 is bigger than 50. But if Dee stays out, then Patrick will advertise because 175 is bigger than 100. So we actually can tell right off the bat, Patrick does not have a dominant strategy. Let's go ahead and finish, though, and see what Dee would do. We know that Dee, if Patrick thinks that they're going to, if Patrick does advertise, Dee would choose to stay out because 0 is better than -2. But at the same time, if Patrick decides to not advertise, then Dee actually would say, I'll go ahead and enter that market and get to 15, and that's better. So we have two Nash equilibria in this situation. So we got to answer C, and our answer for that one was no. And it doesn't even actually ask us for an explanation. So we just say, no, they don't have a dominant strategy. Part D, well, it was a lot easier. Identify the Nash or equilibria for this game. And we've actually identified that there's 2 of them. So we just write those out. We'd say Patrick would say not advertise. And the combo would be Dee enters. Or we would say Patrick advertises and Dee stays out. So I'm just kind of identifying here the 2 strategies and the 2 agents, and that way I'm clearly identifying that this is one of the Nash and this is the other one. Now part E, ignoring antitrust laws, which means basically we're going to let them do what they want to do. Suppose that Patrick pays Dee $20 if Dee chooses to stay out. Redraw the matrix, show how their payment affects the payoffs, and identify the new Nash. So these are a little bit tricky, and it's even made more so because one of the firms is paying the other firm. So we're going to redraw this firm. We have out and enter, and we have advertise and not, and up here we have Dee, and then we have Pat. Now, they're only getting the payment $20 if Dee chooses to stay out. Sorry, whoops, a little bit tilted there. So if Dee chooses to enter, then these values from up here are going to stay exactly the same. It's only the ones on the stay out that'll change. So 50, -2, 150, and 15. 150 and 15. And now for this one, if Dee takes the money, basically, right, then they get $20. But the 175 becomes only 155. I'm sorry, we have to keep shifting that one back and forth. 155 and 20. And again, what we're doing is we're just taking $20 and shifting it from Patrick over to Dee because they stayed out. Now D is going to get 20 bucks if they stay out for the bottom one as well for right here. We're just going to take the 20 bucks away from that 100. So we have 80. So now we've reestablished what the numbers are going to be. We just resolve it. 150 is bigger than 50. 155 is bigger than 80. 20 is bigger than -2, and 20 is bigger than 15. And so pretty clearly the only Nash now is actually up here in the top right. And so for E, we're going to identify it as E2. We're going to say Patrick, advertise, and D, stay out. And so again, you could probably imagine why this would be illegal, would be to pay someone to not open a business. But at the same time, it's kind of like, well, that's the best outcome actually for them combined, if you kind of think about it another way. So it maximizes their combined payoffs. It makes D happy. It's actually better than D would have gotten from operating in any of these outcomes. So no wonder they take the deal. But it's probably not what's best for consumers if we want a competitive market. So hopefully this helped you understand FRQ Prep 3. I'll see you next time.